Hello everyone, welcome back to my YouTube channel, Life Sciences by Dumi Silani. This is a continuation on our lesson series of the endocrine system and homeostasis. Today we will be doing lesson 4, which will be based on the negative feedback between thyroxin and TSH. Before we look at the negative feedback between TSH and thyroxin, I would like for us to remind ourselves of the functions of TSH and thyroxin, as well as which glands secrete these two hormones. Okay, so thyroxin, being the hormone, is secreted by the thyroid gland. Okay, that is that gland that we find over there on the throat area. That is the thyroid gland, and it secretes the hormone thyroxin. All right, now what does thyroxin do again? Thyroxin stimulates the cells of the body to break down glucose and release energy. Okay, and the process is known as cellular respiration. All right, now if you can remember from grade 11 that glucose is fuel for the body. Glucose is fuel. What do I mean by fuel? Glucose is a sugar that contains a lot of energy, and then glucose needs to be broken down, to release energy. In the form of ATP, if you can still remember. You don't need to know the details of this for grade 12 purposes, okay? And this process where the body cells break down glucose to release energy is called cellular respiration. Cellular respiration. Now, we need energy. The body cells require energy for normal bodily activities. Okay? Think of all the metabolic activities that take place within the cell. Things like, what can I think about? Oh, things like DNA replication. That requires energy. Things like protein synthesis. That requires energy. Things like mitosis. That requires energy. So, for the body cells to be able to function well, to do their metabolic or chemical activities, energy is required. Now, to provide energy for the cells to be able to do what they are supposed to do, glucose needs to be broken down to release that energy. Okay, guys? Now, thyroxin is a hormone that stimulates these body cells to break down glucose and release energy. Okay? So, we can say that thyroxin is responsible for increasing cellular respiration or increasing the breakdown of glucose to release energy. So, if thyroxin stimulates body cells to break down glucose to release energy, we can say that thyroxin is responsible for controlling the basal metabolic rate. The basal metabolic rate. Remember that the word rate means the speed, okay? How fast or how slow something is happening. Thyroxin is also responsible for development of the nervous system It is responsible for the development of the brain, and other nerves. Including the development of the spinal cord. All right. So, thyroxin is responsible for the development of the nervous system, including the brain, nerves, as well as the spinal cord. And then lastly, thyroxin improves the function of the heart and the functions of the muscles. Okay, guys? So essentially, we have three functions of thyroxin, three main functions of thyroxin. One, thyroxin controls the basal metabolic rate. Two, thyroxin is responsible for development of the nervous system. And then three, thyroxin improves the functions of the heart as well as the muscles. All right. Now, we have dealt with, or revised rather, the functions of thyroxin. Now, let us look at the functions of TSH. So, TSH, or the thyroid stimulating hormone, is secreted by the pituitary gland. Okay, guys? Now, this is that gland over there at the base of the brain. The gland at the base of the brain. Okay? Now, the pituitary gland is stimulated when there is a need to secrete TSH. What does TSH do? It stimulates the thyroid gland to secrete thyroxin. Okay, remember the word stimulate means to cause. The word stimulate means to cause. Okay, so it causes or stimulates the thyroid gland to secrete thyroxin. Okay, guys, remember the function of the thyroid gland is to secrete thyroxin. Okay, but the thyroid gland cannot do this function on its own. It needs to be stimulated, meaning when there is a need, the pituitary gland will secrete more TSH. The TSH will travel by the blood to the thyroid gland. And when the thyroid gland receives TSH, it is then that it can start secreting thyroxin. So, I repeat, the function of the thyroid gland is to secrete thyroxin. However, it needs to be stimulated. It cannot do this on its own. It needs to be stimulated by TSH in order to do that. So, when the pituitary gland secretes no TSH, it means that the thyroid gland does not secrete thyroxin. Okay? When the pituitary gland secretes TSH, it means that the thyroid gland will be stimulated to secrete thyroxin. So we can safely say, when there is TSH, when the pituitary gland secretes TSH, then the thyroid gland will secrete thyroxin. However, when the pituitary gland does not secrete TSH, then the thyroid gland cannot secrete thyroxin. So the functioning of the thyroid gland is dependent on the availability of TSH. Okay, guys? With that being said, let's move on to the next slide. Okay, what we have here is the pituitary gland. And then in terms of its functioning or its relationship to the thyroid gland, we said that the pituitary gland secretes TSH. As you can see, the TSH will travel by the blood and then it will act on the thyroid gland. When more TSH is secreted, it stimulates the thyroid gland to secrete more thyroxin. But if there is less TSH, then the thyroid gland will secrete less thyroxin. Okay, guys? Sounds simple. Okay. Now let us look at the contextual responses to this type of question. So you can get a question where they say, describe the negative feedback between the pituitary gland and the thyroid gland when thyroxin levels are below normal in the body. So when thyroxin levels are below normal in the body, remember, negative feedback has two components. The negative feedback mechanism works like this. When there are normal levels, or constant levels of a substance, all is good and well, all is great. However, when there is an increase in levels of a substance, something must happen there. Okay? Something must detect this, that's a sudden increase, and then something in the body also, something must be done to decrease the levels back to normal. And then we say we have maintained homeostasis. Again, when the levels of a substance go down, negative feedback kicks in. There must be something in the body that will detect that there's a decrease, one. And secondly, something must happen to restore or to increase the levels of that substance back to normal, to maintain homeostasis, back to normal. Okay, so negative feedback, just to remind you, involves two things. Involves detection of an imbalance, either an increase or a decrease below normal, and then, detection. And then secondly, restoring balance. restoring balance. That's what negative feedback involves. Now, here, when thyroxine levels are below normal, so we are looking at when there is a decrease in thyroxine levels. What is going to detect and how is restoration of balance going to be ensured? So this is what happens. The pituitary gland is stimulated, okay, to do what? To secrete more TSH. Remember, what is the function of TSH? TSH stimulates the thyroid gland to secrete thyroxin. So when more TSH is secreted, it means that it will cause the thyroid gland to secrete more thyroxin. More thyroxin. Remember, thyroxin levels decreased below normal. So when more thyroxin levels are secreted by the thyroid gland, then it means the thyroxin levels will increase back to normal. Is that what's going to happen? Yes. Thyroxin levels increase. Please do not say go back to normal. You must say increase back to normal. Okay. Now, when thyroxin levels are above normal, so in this case, thyroxin levels started at normal, then thyroxin levels increased above normal. What's going to happen to reduce the thyroxin levels back to normal? Okay, let's check. Again, the pituitary gland is stimulated. It secretes less TSH. Again, remember, when the pituitary gland secretes less TSH, what is the function of TSH again? The function of TSH is to stimulate the thyroid gland from secreting thyroxin. So if less TSH is secreted, it means that the thyroid gland will secrete less thyroxin. Okay? And then the thyroxin levels will decrease. When they decrease back to normal. Okay, guys? Now here, remember, very important, function of the of TSH is to make the thyroid gland secrete thyroxin. So when there is less TSH, when the pituitary gland secretes less TSH, it means it will cause the thyroid gland to also secrete less thyroxin. Okay. When the pituitary gland secretes more TSH, then it will cause the thyroid gland to secrete more thyroxin. Okay, guys, let's move on to the next slide. So here we have a schematic representation of the responses that we established on the previous slide. So here we have normal levels of TSH. Okay, so everything is normal. Everything is all good and well. Okay, however, let's check. When thyroxin levels decrease below normal, when thyroxin levels decrease below normal, okay, what do we need to do? We need to increase the thyroxin levels. Okay, what's going to happen? Remember, we said that the pituitary gland is stimulated to secrete more TSH. And if more TSH is secreted, remember what is the function of the TSH? Is to cause the thyroid gland to secrete more thyroxin. So, more thyroxin will be secreted by the thyroid gland. Okay? When more thyroxin is secreted by the thyroid gland, then it means thyroxin levels are going to increase. Now, when thyroxin levels increase, they increase back to normal. And we have maintained homeostasis. Okay, thyroxin levels are back at normal. All is good and well. However, if the thyroxin levels rise above normal, what is going to happen? The pituitary gland is stimulated and it secretes less TSH. Okay, guys? Now, what did we say? When we have more TSH, then the thyroid gland will secrete more thyroxin. In this case, we have less TSH. It means if we have less TSH, the thyroid gland will secrete less thyroxin. So, if the pituitary gland secretes less TSH, then the thyroid gland will secrete less thyroxin. So when less thyroxin is secreted, it means that the thyroxin levels will decrease. Now, when they decrease, they don't only decrease, they decrease back to normal. Back to normal. Remember the rule, guys. I'm reminding you for the last time. Remember the rule. More TSH that is secreted by the pituitary gland equals more thyroxin. Thyroxin that is secreted by the thyroid gland. If the pituitary gland secretes less TSH, it means that the thyroid gland will secrete less thyroxin. Less thyroxin. Okay, now let us establish when does the pituitary gland secrete more TSH. More TSH is secreted by the pituitary gland when the body has low thyroxin levels. When the body has low thyroxin levels, then the pituitary gland secretes more TSH and it will cause the thyroid gland to secrete more thyroxin, thereby increasing thyroxin levels back to normal. But when does the pituitary gland secrete less thyroxin? Less thyroxin is secreted when the body has too much thyroxin. When the body has too much thyroxin, meaning thyroxin levels are above normal. Okay? So, when we have too much thyroxin, it means that we need less thyroxin to be secreted by the thyroid gland. Therefore, the pituitary gland will secrete less TSH. Okay, so less TSH is secreted when we have too much thyroxin. So if we have less TSH secreted by the pituitary gland, it means that the thyroid gland will be stimulated to secrete less thyroxin. Okay, guys? I believe this negative feedback is pretty much simple. Okay, it is not as difficult as others would be. For example, glucose levels that are controlled by glucagon and insulin that we did in the previous lesson. Okay, with that being said, ladies and gentlemen, this is the end of the lesson itself. However, as usual, we are going to look at some exam type questions in the following slides. Continuing with the lesson, we need to look at disorders associated with thyroxin. All right, let's look at the introduction. In certain situations, hormone secretions are disturbed, and this affects homeostasis. Endocrine glands can either secrete too little or too much of the hormone. When too little is of a hormone is secreted, that will be known as hyposecretion. And when there's too much of a specific hormone that is secreted, that will be known as a hypersecretion. If it continues, a person would be diagnosed with an endocrine disorder. So we don't want too much of a hormone to be secreted, and definitely we don't want too little of a hormone to be secreted. We need just the right amount. So, a disorder that is prescribed for you by your examination guidelines is known as goiter. Please mind the spelling. Now, what is goiter? Goiter leads to an abnormal increase in the size of the thyroid gland. So it means that the thyroid gland becomes inflamed and it becomes bigger than it actually is. What is the cause of this goiter? It is caused by a lack of iodine. Remember, thyroxin is an iodine-containing hormone. Okay, so it means that there should be enough iodine in your diet so that the thyroid gland can make and secrete a sufficient amount of thyroxin. So, a goiter, which is an inflammation or a growth of the thyroid gland, is caused by rather a lack of iodine. So, it is caused by a lack of iodine in the diet of a person. Other symptoms of goiter includes increased metabolic rate, increase in heartbeat, and an increase in blood circulation activity, an increase in anxiety. Anxiety is the feeling of anxiousness. Okay, always being anxious, always being wary of your surroundings, always being nervous, always being extra cautious. All right, so what does a goiter look like? A goiter looks like this. Remember, the thyroid gland is found in the neck area, just below your lower jaw. Okay, now remember what we said a goiter is? We said that a goiter is an abnormal increase in the size of the thyroid gland. So as you can see, there is a goiter. It is caused by a lack of iodine. Okay, so if there's a lack of iodine in the diet, then the the thyroid gland will inflame or become abnormally bigger. And then the symptoms of goiter may be increase in metabolic rate, meaning an increase in energy production, increase in heartbeat, increase in blood circulation, as well as an increase in anxiety. So this is the only disorder that is prescribed for you by the examination guidelines. Okay, guys? Okay, so that was the end or the conclusion of the lesson. Simple and straight to the point. Please make sure to take some notes. Please make sure to go back to the work, practice the negative feedback between TSH as well as thyroxin, the functions of thyroxin and TSH, know which gland secretes which hormone, and we are going to apply the knowledge that we have attained in this lesson in the following video, where we are going to look at exam type questions based on lesson 4. With that being said, ladies and gentlemen, I will see you on that video. Goodbye.